New Guinea, 1943. If you were to take a map of the world and look for the place least suited for the operation of high-performance, precision-engineered machinery, you would put your finger on the island of New Guinea. To the pilots of the United States 5th Air Force, this place was not a tropical paradise. It was a biological weapon. It was a land where the mountains rose from the sea like the jagged teeth of a saw, climbing to 15,000 feet in a matter of miles. It was a land where the air was not a gas, but a super-suffocating blanket of water vapor that hung at a permanent 95% humidity. In this environment, metal did not just rust. It dissolved. Fungus grew on the delicate optical glass of bomb sites within 24 hours. Leather boots rotted off the feet of infantrymen in a week. And malaria, carried by the clouds of mosquitoes that swarmed the lowlands, killed more men than the Japanese Imperial Army. The Japanese commander's men, like General Hatazo, a Daki of the 18th Army, looked at this terrain and saw an ally. They believed that the soft Americans, with their reliance on complex supply chains, ice cream barges, and heavy technology, would bog down in the mud. They believed that the jungle was the great equalizer. They believed that in the green hell, the spirit of the warrior mattered more than the horsepower of the machine. They were right about the terrain. It was a nightmare. But they were wrong about the Americans. Specifically, they were wrong about the American mechanic. They did not understand that the U.S. Army Air Forces had brought a secret weapon to the Pacific. It wasn't a bomb. It wasn't a plane. It was a culture. A culture of farm boys from Kansas and hot rodders from Detroit who refused to accept the laws of physics. A culture that looked at a broken machine and didn't see trash, they saw a challenge. This is the story of the ultimate expression of that culture. It is the story of a single aircraft, a Lockheed P-38 Lightning that was written off by the bureaucracy, abandoned by the supply chain, and left to rot in the weeds. It is the story of how one man, a staff sergeant with no engineering degree and no factory support, decided to resurrect that dead machine using the only materials he had, scrap metal soup cans and the trees of the jungle itself. This is the story of the Jungle Lightning. To understand the magnitude of the mechanical heresy we are about to describe, you first have to understand the machine itself. In 1943, the Lockheed P-38 Lightning was not just an airplane. It was the crown jewel of American aeronautical engineering. It was the aluminum god, while the Japanese were flying the Mitsubishi, a 6M0, a lightweight, nimble fighter made of magnesium and wood. Sacrificing armor for range, the P-38 was a flying tank. It was a twin-engine monster. It was the brainchild of the legendary Kelly Johnson, a man who would later go on to create the SR-71 Blackbird. Johnson never intended the P-38 to be a mere dogfighter. He designed it to dominate the stratosphere. Its heart was a pair of Allison V-171 liquid-cooled V-12 engines, working together to unleash nearly 3,000 horsepower. It became the first American fighter to break 400 miles per hour in level flight, an unheard of speed at the time. And its firepower was unlike anything in the sky. While other fighters struggled to synchronize their guns through the propeller arc, the P-38 mounted all its weapons in a central nacelle. 4 50-caliber machine guns and a 20mm Hispano cannon firing straight ahead with no need for convergence. It didn't spray bullets, it delivered a laser-straight beam of lead. A 3-second burst was enough to cut a Japanese bomber in half. But all this performance came with a steep one: complexity. The P-38 was a plumber's nightmare. Inside its sleek aluminum skin was a labyrinth of hydraulic lines, electrical conduits, and turbo-supercharger ducting. It had twin radiators, twin booms, and a tricycle landing gear system that was notoriously fragile. The structure of the aircraft was revolutionary. It used a stressed skin monocoque design. In older planes, the internal frame carried the load, and the skin just covered it. In the P-38, The skin was the structure. The aluminum sheets were flush riveted, smooth as glass, and engineered to tolerances measured in thousandths of an inch. The twin tail booms, which held the engines and the tail surfaces, were delicate tubes of tension and compression. If they were dented, the strength was gone. If they were misaligned by a fraction of a degree, the airflow would be disrupted, and the plane could tear itself apart in a high-speed dive due to compressibility effects. Because of this complexity, the United States Army Air Forces, USAF, technical orders were crystal clear. They were written in stone at Wright-Patterson Air Force Base. The manual stated that the P-38 required a paved runway. It required a hangar. It required a full team of factory-trained specialists to maintain. And crucially, it stated that if a P-38 suffered major structural damage to the tail booms, it was a Class 26 write-off. Class 26 meant damaged beyond repair. It meant you didn't try to fix it. You stripped the useful parts, the radios, the guns, the instruments, and you pushed the carcass into a ravine to rot. That was the logic of the Pentagon. That was the logic of the factory. But in the fall of 1943, at a muddy, malaria-infested strip called Cororo, the logic of the Pentagon collided with the reality of Staff Sergeant Jake McKinley. Who was Jake McKinley? He wasn't a pilot. He wasn't an officer. He was a grease monkey, a staff sergeant. In the grand hierarchy of the U.S. Army, he was a nobody. But in the ecosystem of the 5th Air Force in New Guinea, men like McKinley were the high priests of survival. McKinley belonged to a unit that didn't get the glory. He was part of the 25th Liaison Squadron. They called themselves the Guinea Short Lines, while the fighter jockeys in the P-38s and P-47s were racking up kills and getting their pictures in the papers. The 25th Liaison Squadron was doing the dirty work. They flew the Stinson L-5 Sentinel, the flying Jeep. The L-5 was the antithesis of the P-38. It was a fabric-covered, tube steel kite powered by a 185 horsepower Lycoming engine. It was slow, unarmed, and ugly. But it could do things a P-38 couldn't. It could land on a sandbar in a river. It could take off from a muddy track cut into the side of a mountain. The pilots of the 25th were often enlisted men sergeants who flew like maniacs. They were the jungle taxi service. They flew in blood plasma and ammo to surrounded infantry units. They flew out the wounded, strapped to stretchers. They dropped supplies to the Australian commandos fighting behind Japanese lines. And because they were a bastard unit operating on the fringes of the supply chain, they got nothing. The big fighter groups at Port Moresby and Nadzab got the new parts, the new engines, the fresh tires. The 25th got the scraps. This forced their mechanics, like Jake McKinley, to become scavengers. They became masters of field expedient repair. If an L-5 blew a tire and there were no spares, they would stuff the tire with grass and fly it anyway. If a cylinder head cracked, they would weld it. If a control cable snapped, they would weave a new one from fencing wire. McKinley lived in a world where the manual was just a suggestion. The only rule that mattered was, does the engine turn? Does the wings stay on? He had developed a reputation. He was the guy you went to when the answer from the supply officer was no. He was a wizard with a welding torch. He could look at a pile of rusted junk and see a carburetor. But nothing McKinley had ever done, no amount of baling wire engineering could prepare him for what fell out of the sky one afternoon in late 1943. It began with the sound. The men of the 25th were used to the buzz of the little Lycoming engines. But this was different. It was a low, guttural roar that shook the palm fronds. It was the sound of twin Allisons screaming in distress. High above the Cororo strip, a P-38 Lightning appeared. It was trailing smoke. One prop was feathered dead and stationary. The other was surging. The aircraft was crab-walking through the air, fighting a crosswind an asymmetric thrust. This wasn't a liaison plane. This was a combat bird. A killer. It belonged to one of the premier fighter groups, perhaps the 8th, Headhunters, or the 49th. It had likely been on a long-range escort mission to Rabaul or Wook and had been mauled. Maybe it was Zeros. Maybe it was ground fire. Maybe it was the weather. The pilot was in trouble. He saw the tiny cut in the jungle that was the Cororo strip-a-strip designed for L5 South, not for a 15,000-pound fighter with a landing speed of 100 miles per hour. But he had no choice. He dropped the gear. From the ground, McKinley and the other mechanics watched the drama unfold. They saw the big fighter line up. They saw it flare. They saw the pilot fighting the yoke, trying to keep the wings level as the stall warning screamed. The P-38 hit the mud. It hit hard. The nose gear, designed for concrete, dug into the soft slime of the jungle floor. It snapped instantly. The nose of the beautiful fighter slammed into the earth. The props, still spinning, struck the mud. The tips curled back like banana peels. The engine screamed as they ground to a halt, but the momentum was too great. The aircraft slewed sideways. It ground-looped a violent, uncontrollable spin on the ground. The tail booms whipped around. The horizontal stabilizer smashed into a stand of trees at the edge of the runway. There was a sickening crunch of metal, the sound of aluminum tearing like paper. Then, silence. The mechanics of the 25th ran to the wreck. They pulled the pilot out of the cockpit. He was shaken, bruised, maybe a few broken ribs, but alive. He looked at his plane, his beautiful $97,000 weapon of war, and shook his head. "She's done," he said. And he was right. An Air Force recovery team arrived a few days later aboard a C-47. An engineering officer stepped out, walked slowly around the wreck, and began taking notes. He didn't need long. The propellers were destroyed. The nose gear had been sheared clean off. Both engines were seized and shock-loaded beyond repair. And the empennage, the entire tail assembly, had suffered catastrophic structural failure. The officer finally stopped at the tail booms. The delicate monocoque tubes were buckled, their metal skin torn open and hanging in ribbons. The internal bulkheads were twisted out of shape, and the alignment, that precise geometry that kept the aircraft stable at 400 miles an hour, was gone. "Class 26, the officer said. "Total loss. Strip the radio and the guns. Leave the rest. It was the only logical decision. You cannot fix a P-38 tail boom in the jungle. You need a jig. You need an autoclave. You need factory-spec alclad aluminum sheets." The recovery team took the valuable bits, the 50 cals, the radio, the bomb sight. They loaded them onto their transport and flew away. They left the carcass of the P-38 sitting in the tall kunai grass at the edge of the strip. A dead king, rotting in a foreign land. For most men, that would have been the end of the story. The jungle would claim the plane. Vines would grow over the cockpit. The aluminum would oxidize into white powder. In 10 years, it would be a lump of mossy metal. But Jake McKinley couldn't let it go. For weeks, McKinley walked past the wreck every day. He would stop and look at it. Even broken, even covered in mud, the lines of the P-38 were captivating. It was the pinnacle of American technology. It represented everything that McKinley loved about machines, power, speed, purpose. Leaving it there felt like a sin. It offended his mechanic's soul. He started spending his evenings by the wreck. At first, it was just curiosity. He cleared away the vines. He cleaned the mud out of the cockpit. He sat in the pilot's seat and imagined what it must have felt like to fly it. Then he started tinkering. He opened the engine cowlings. He looked at the seized V-12s. He took a wrench and tried to turn the crank. It wouldn't move, but McKinley knew engines. He knew that seized didn't always mean dead. Sometimes it just meant mud in the cylinders. He started taking the engines apart. He cleaned the pistons with gasoline. He polished the cylinder walls. He scavenged gaskets from wrecked trucks. He worked by the light of a lantern, fighting off the mosquitoes, sweating in the humid night. After a week, he got the left engine to turn over by hand. A week later, the right engine turned. They weren't dead. They were sleeping, but the engines were the easy part. The tail was the impossible part. McKinley stood at the back of the plane and looked at the shattered booms. The metal was torn open. The structural integrity was zero. If you tried to fly this plane, the tail would rip off the moment you pulled back on the stick. He needed aluminum. He needed sheet metal. He needed rivets. He had none of those things. The supply chain to Cororo was barely bringing in enough food and ammo for the L-5 South. There was no way he could order a P-38 tail section. He looked around the strip. He saw mud. He saw rusted Quonset huts. And he saw the jungle. He saw the towering hardwood trees that surrounded the base. Ironwood, mahogany, trees that had stood for centuries. Wood that was dense, heavy, and strong. And a crazy idea began to form in Staff Sergeant McKinley's mind. He remembered the stories of the de Havilland Mosquito, the British bomber made entirely of plywood. He remembered that the earliest airplanes were made of wood and fabric. He thought, stress is stress. Load is load. The air doesn't care if the structure is made of aluminum or wood, as long as it holds. He walked into the mess tent that night. The other mechanics were playing cards, drinking jungle juice. "I'm going to fix that P-38, McKinley announced. The tent went quiet. A few guys chuckled. "With what, Jake?" one of them asked. "We don't have parts. We don't have metal." "I don't need metal," McKinley said. "I've got trees." The laughter stopped. They looked at him. They saw the look in his eyes. It was the look of a man who had stared at a problem for so long that the impossible had started to look possible. "You're going to build a 400-mile-an-hour fighter plane out of logs?" The crew chief asked. "That's exactly what I'm going to do," McKinley said. This was the moment of hubris versus nemesis. The hubris of the factory manual said, "This machine is too complex for you. You are just a sergeant. You cannot understand the stress loads of a monocoque boom." The nemesis was Jake McKinley. The nemesis was the American spirit of can do. He wasn't going to restore the plane to factory specs. He was going to reinvent it. He was going to build a Frankenstein monster, a hybrid of 1940s aerospace technology and Stone Age construction materials. And he was going to make it fly. The next morning, Staff Sergeant Jake McKinley ceased to be an aircraft mechanic. He became a lumberjack. He took a team of men from the 25th Liaison Squadron out into the jungle perimeter. They weren't looking for Japanese patrols. They were looking for specific trees. McKinley needed wood that was dense, straight-grained, and resistant to the rot that consumed everything in New Guinea. He needed ironwood or mahogany. When they found the right trees, they didn't have a sawmill. They had axes and machetes. They felled the timber and dragged the logs back to the muddy revetment where the broken P-38 lay. Now began the most surreal engineering project of the Pacific War. The tail booms of a P-38 are not just empty tubes. They are complex, semi-monocoque structures. They have to handle the torque of a 1,475 horsepower engine pulling in one direction and the drag of the tail surfaces pulling in the other. They have to withstand twisting forces, bending forces, and the violent vibrations of combat maneuvering. Lockheed built them using hydroformed aluminum bulkheads and stressed duralumin skin, assembled in a dust-free factory in Burbank by workers wearing white cotton gloves. McKinley was about to rebuild them using a hatchet and a draw knife while standing knee-deep in mud. He stripped away the torn aluminum skin from the shattered sections of the booms. He examined the bent metal longerons, the spine of the aircraft, They were kinked beyond repair, so he cut them out. In their place, he began to insert hand-hewn wooden beams. He treated the fighter plane like a timber frame house. He fashioned internal bracing struts from the ironwood. He didn't have blueprints for a wooden P-38 because none existed. He had to intuitively understand the load paths. He had to visualize where the stress would go when the plane pulled a high G turn. He used wood screws and bolts scavenged from wrecked trucks to secure the timber to the remaining metal bulkheads. Where the metal skin was torn but salvageable, he hammered it flat against the new wooden skeleton. It was a bizarre hybridous cyborg of metal and organic matter. To the other mechanics watching, it looked insane. You don't put wood inside a high-performance metal fighter. Wood swells with moisture. Wood rots. Wood doesn't expand and contract at the same rate as aluminum. But McKinley had a theory. He figured that the internal volume of the boom was sealed enough that, if he greased the wood heavily, it might hold its dimension long enough for a flight. He wasn't building it to last 10 years. He was building it to last 1 hour. While McKinley wrestled with the carpentry, his team went to work on the skin. The crash had ripped gaping holes in the aluminum plating of the booms and the central nacelle. Aerodynamically, these holes were disasters. They would create drag that could buffet the tail into failure. They had to be patched. But there was no sheet aluminum at Cororo. The supply officers at the big bases laughed when the Guinea Short Lines asked for aircraft-grade metal. So McKinley turned to the trash heap. The base was littered with empty 55-gallon fuel drums and tin cans from the mess hall cans that had once held Spam, beans, and soup. This was steel, not aluminum. It was heavier. It reacted chemically with aluminum, causing corrosion. But it was flat, and it was available. The mechanics cut the tops and bottoms off the cans. They hammered them flat on tree stumps. They used tin snips to shape them into patches. Then came the problem of attaching them. They didn't have flush rivets. They didn't have rivet guns. They used stove bolts. They used screws. In some places, it is rumored they used nails driven through the wood bracing and clinched over on the other side. The result was an aerodynamic horror show. The sleek, laminar flow skin of the P-38, designed to slip through the air at 400 miles per hour, was now covered in lumps, bumps, and screw heads. It looked like a boiler explosion in a shrapnel factory. But McKinley ran his hand over the patches. They were solid. They wouldn't tear off in the slipstream. Now came the hardest part. The part that should have been impossible. Alignment. A P-38 is a twin-boom aircraft. The two tails must be perfectly parallel. The horizontal stabilizer that connects them must be perfectly perpendicular to the center line of the aircraft. If the tails are misaligned by even a fraction of a degree, the aircraft will crab through the air. The drag will be asymmetrical. At high speeds, this can cause a phenomenon called aeroelastic flutter. The tail starts to vibrate. The vibration amplifies. Within seconds, the tail rips off, and the plane disintegrates. At the Lockheed factory, they used massive steel jigs rigid frames that held the parts in exact position while they were riveted. They used optical transits and laser-precise measurements. McKinley had a ball of twine and a ruler. He tied a piece of string to the nose of the central pod. He ran it back to the center of the horizontal stabilizer. He measured the distance to the tip of each vertical fin. He used the plumb bob method, a weight hanging on a string to check the vertical alignment of the rudders. He adjusted his wooden internal bracing, shimming it with slivers of wood, tightening a bolt here, loosening one there, until the string measurements were equal. He did this in the heat of the day, with sweat dripping into his eyes. He did it while fighting off malaria chills. He stood back, squinted at the plane, and made adjustments by eye. "Look straight to me," he said. It was an act of supreme confidence. He was betting a pilot's life on his eyesight and a piece of string. While the airframe was being Frankenstein together, the engines needed a miracle. The twin Allison V-1710s had hit the mud at full power. The sudden stoppage had shock-loaded the crankshafts. In a normal maintenance environment, these engines would be condemned. The crankshafts could be cracked. The connecting rods could be bent. McKinley didn't have the equipment to magniflux the parts for cracks. He didn't have X-ray machines. He drained the oil. It was full of sludge and water. He flushed the crankcases with gasoline, a dangerous practice that filled the revetment with explosive fumes. He pulled the spark plugs and poured oil into the cylinders. He built a giant lever arm that bolted onto the propeller hub. He and two other men hung on the bar, trying to force the engine to turn. It wouldn't budge. The rings were rusted to the cylinder walls. They poured in more solvent. They waited. They tried again. Creak. The piston broke free. They turned it a quarter turn, then a half turn. Slowly, painfully, they worked the engines free. They scavenged new spark plugs from a wrecked truck. They patched the ignition wires with electrical tape. They cleaned the carburetors, which were packed with dried mud. But they had no propellers. The original props were twisted scrap. This was the one thing McKinley couldn't make out of wood. A P-38 propeller is a constant speed, variable pitch mechanism. It has to handle immense centrifugal loads. A wooden prop would shatter. McKinley had to barter. The pilots of the 25th Liaison Squadron flew their L-5S into the big bases at Port Moresby. They carried war souvenirs, Japanese swords, flags, and Arisaka rifles captured by the infantry. These souvenirs were gold to the supply sergeants in the rear echelon. A deal was struck. A crate of Japanese rifles for 2 Curtiss electric propellers. The props arrived. They were bolted on. The jungle lightning was complete. It sat in the clearing, a patchwork nightmare. The paint was faded and mismatched. The tail booms were bulky and misshapen, where the wooden bracing bulged against the skin. The rivets were replaced by rows of mismatched bolt heads. The skin was a quilt of fuel-drum steel and aluminum. It looked like something out of a junkyard. The pilot who had crashed, it was long gone. The other pilots of the 25th looked at it with a mixture of awe and horror. They flew L-5S. They knew that this machine, with its 3,000 horsepower and critical aerodynamics, was a beast they weren't qualified to tame. But McKinley wasn't done. He hadn't built it to look at it. He had built it to fly. He needed a test pilot. Rumors spread through the jungle. There was a crazy sergeant at Cororo who had built a P-38 out of trees. Most people dismissed it as a latrine rumor, bored soldiers making up stories. But then, a ferry pilot, a man whose job was to fly repaired aircraft from the depots to the front, found himself stranded at Cororo. His transport had broken down. He was stuck in the mud, waiting for a ride. He saw the P-38 sitting in the weeds. He walked over to it. He saw the wood. He saw the bolts. He found McKinley. "Does it run?" the pilot asked. "It runs," McKinley said. "Will it fly?" McKinley looked him in the eye. "I'd bet my stripes on it," the pilot laughed. "Sergeant, if this thing crashes, you won't have any stripes. And I won't have a head." But the pilot was bored, and he was curious. And in the culture of 1943, that was enough. "Fuel it up," the pilot said. "Let's see what she does." The pilot walked around the aircraft one last time. His name is lost to the official records, likely a ferry pilot from the 308th bomb, wing or a transport jockey looking for a thrill. But his skepticism is a matter of legend. He kicked the tires. He tapped his knuckles against the fuselage. It didn't ring like aluminum. It thudded. It felt dead. "You realize," he told McKinley, "that if those wooden spars warp in the humidity, the tail is going to twist off. And if the tail twists off, the pod goes into a tumble, and I won't be able to bail out." McKinley nodded. He didn't offer reassurance. He didn't offer engineering calculations. He just wiped his grease-stained hands on a rag and said, "It won't warp. I used ironwood. It's harder than the aluminum." The pilot climbed the ladder into the central pod. The cockpit smelled of mildew and high-octane fuel. The plexiglass canopy, scavenged from another wreck, was scratched and yellowed by the sun. He strapped in. He flipped the master switch. The gauges flickered to life. Outside, the ground crew stood back. There were no fire trucks. There were no ambulances. If this went wrong, the only fire suppression would be the wet mud of the jungle floor. Clear prop. The pilot engaged the starter on the left engine. The prop turned slowly, whoosh, 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 and then the Allison V-1710 caught. It coughed a cloud of blue smoke, cleared its throat, and settled into a low, menacing rumble. Then, the right engine. The vibration was immediate. The P-38 was always a vibrating machine, but this was different. The pilot could feel the wood in the airframe dampening the harmonics. It felt heavy, solid, like a piece of furniture rather than a flying machine. He ran up the throttles to check the mags. The plane strained against the brakes. The wooden tail booms shook violently in the prop wash. McKinley watched the bolts. He watched the soupkin patches. They held. The pilot gave a thumbs up. He released the brakes. The P-38 didn't leap forward. It lumbered. It was hundreds of pounds heavier than a stock Lightning. The mud of the Cororo strip sucked at the tires. The trees at the end of the runway loomed larger and larger. 60 miles per hour. The rudders became effective. The pilot danced on the pedals, keeping it straight. 80 miles per hour. The nose wheel felt light. 100 miles per hour. He pulled back on the yoke. This was the moment of critical failure. The elevator would bite the air and force the tail down. The stress on the wooden booms would shift instantly from compression to tension. If McKinley's joinery was weak, the tail section would snap off right now, and the pod would somersault into the jungle at 100 miles per hour. The nose rose. The main gear broke contact with the mud. The jungle Lightning was airborne. A cheer went up from the mechanics that was loud enough to be heard over the engines. They threw their caps in the mud. They hugged each other. McKinley just stood there, hands on his hips, watching his creation climb into the tropical sky. Inside the cockpit, the pilot wasn't cheering. He was sweating. The plane flew, but it flew like a dump truck. It was nose-heavy. The center of gravity had shifted aft due to the heavy timber in the tail, but the repairs to the nose gear had added weight forward. The trim tabs were screaming for relief. He kept the gear down. He didn't trust the hydraulics to retract them, and if they got stuck halfway, he'd have to belly land this wooden monster, which would surely shatter the frame. He circled the field once, banking gently. He treated the yoke like it was made of glass. No high G turns. No sudden movements. He just wanted to get it to the main base at Nadzab, 40 miles away. He leveled off at 2,000 feet. Below him, the green carpet of New Guinea stretched out unforgiving, endless. If he went down now, he'd be just another missing airman in the aluminum trail. Nadzab Airfield was the hub of 5th Air Force operations. It was a sprawling complex of paved runways, revetments, and hangars. It was where the real Air Force lived, the generals, the aces, the tech reps. When the tower controllers at Nadzab spotted the lone P-38 approaching with its gear down, they assumed it was a combat bird in trouble. They cleared the airspace. Fire trucks rolled out. The pilot lined up on the main runway. He cut the power. The heavy plane sank like a stone. He flared late, planting the main wheels firmly on the Marston matting. The nose came down. He braked. The plane rolled to a stop. He taxied to the transient ramp, shut down the engines, and popped the canopy. By the time he climbed down, a crowd had gathered. Line mechanics, curious pilots, and supply officers surrounded the plane. At first glance, from 50 feet away, it looked like a normal, war-weary P-38. Then they got closer. They saw the rows of mismatched bolts. They saw the patches made from flattened resonant fuel drums, complete with the stenciled warning labels still visible. They saw the bulging, non-standard contours of the tail booms. A murmur of confusion rippled through the crowd. What the hell is that? Then, a man in a clean khaki uniform pushed through the crowd. He carried a clipboard. He looked like he didn't belong in the jungle. He was a Lockheed technical representative. A tech rep. These men were civilians sent by the factory to advise the Air Force. They knew every rivet, every wire, every stress tolerance of the P-38. They were the high priests of the manual. The tech rep walked up to the tail boom. He tapped it. Thud. He frowned. He took out a penknife and scratched the paint. Underneath the olive drab, he didn't find aluminum. He found dark red ironwood. He looked at the pilot. He looked at the plane. His face went pale. Who signed this off? He demanded. Where is the Form 1A? Who authorized a structural repair with ... with lumber? The pilot lit a cigarette, his hands shaking slightly now that the adrenaline was fading. He pointed back toward the mountains. A staff sergeant up at Cororo, the pilot said. Name's McKinley. The tech rep was incredulous. A sergeant? A sergeant decided to redesign the stress-bearing structure of a 400-mile-an-hour fighter plane with tree trunks? He didn't just decide, the pilot said. He did it. And it flew. The inspection that followed was thorough and brutal. The tech rep summoned an engineering team. They opened the inspection panels. They crawled inside the booms. They measured the alignment. They expected to find a death trap. They expected to find cracked spars, twisted longerons, and imminent catastrophic failure. They prepared to write a report that would have McKinley court-martialed for endangering a pilot's life and destroying government property. But as they looked deeper, their expression changed from horror to begrudging respect. They realized that McKinley hadn't just stuffed the boom with wood. He had engineered it. He had identified the primary load paths, the lines of force that traveled from the tail surfaces to the wing roots. He had aligned the grain of the ironwood to match those paths. He had used the wood as natural flexibility to absorb the vibration that would have cracked a rigid metal repair. He had built a truss structure inside the boom that mimicked the design of a bridge. It was crude. It was heavy. It violated every specification Lockheed had ever written. But it was strong. The tech rep climbed out of the boom, wiping grease from his hands. He looked at the gathering crowd of officers who were waiting for his verdict. Well, a colonel asked, is it scrap? The tech rep looked at the wooden tail. He looked at the soup tin patches. Technically, the rep said, it shouldn't fly. Aerodynamically, it's a disaster. But structurally ... double key. Paused. It's solid as a rock. That wood is stronger than the aluminum we use. He pulled out a stencil and a can of yellow paint. On the side of the nose, he painted a warning. Restricted. Ferry only. Nitrogen monoxide acrobatics. Do not exceed 200 mph. It was a victory. The jungle lightning was officially airworthy. It was never used in combat. The weight penalty was too high, and the risk of the wood rotting in the humidity was too great for long-term service. It was eventually stripped for its engines and instruments, and the wooden airframe was pushed into a boneyard. But the legend was born. The story of Jake McKinley and his wooden P-38 raced through the 5th Air Force. It became a morale booster. It told every mechanic, every pilot, and every supply clerk that the rules didn't apply here. It reinforced the core American doctrine of the war. If it works, it's right. The Japanese, meanwhile, were still operating by the book. If a Zero's wing spar cracked, they waited for a factory replacement from Nagoya. If they didn't have the part, the plane sat. They had brilliant engineers, but they didn't have a culture that empowered the sergeant in the field to redesign the airplane. McKinley's wooden tail boom was more than a repair. It was a symptom of why the Axis powers were going to lose. They were fighting a nation of tinkerers, a nation of men who refused to accept that a machine was broken just because the manual said so. Jake McKinley was one man, but he was not an anomaly. He was part of a massive, decentralized machine of American industrial dominance that was slowly crushing the Japanese Empire.